Hi, I'm Carl with Nitro Gear and Axle.
I'm Jared.
And we're here today to talk about some Ford 9-inch stuff. We've got a pretty cool, new exciting product line we're going to be launching. It's the Nitro Pro series of differential parts that is kind of to set a new standard for upper end of things for drag racing, Baja racing, Ultra 4, heavy type competition stuff that needs more than even your standard upgraded parts. What we've got here is a few different Ford 9-inches. Stock one, cast iron dropout, takes a 28 spline pinion, either 28 or 31 spline axles. This is a aftermarket nodular unit, a considerable upgrade from that, much stronger, beefier case design. Can be equipped with 28 or 35 spline pinion, and then with a 28, 31, or 35 spline axle shafts, or 40. Here we have the Pro Series Billet Aluminum third member. This can accommodate all kinds of stuff. 9-inch gears. We do a street version that takes a 28 spline pinion. We do a Pro version that takes a 35 spline, 9-inch gear, 9.5 gear, or even a 10-inch gear. And this is a new one that's got a larger bearing bore to accommodate the big 40 spline stuff for some serious power. This one is actually, you may have heard of a show called Street Outlaws, and a guy named Doc who's got a car, you've probably seen the Street Beast, this is what we're setting this rear end up for. It's going to be installed, and we're going to see what he can do to put it through its paces. Some of the key differences here, with a stock dropout, you've got, I don't know if you can see, you might need to get closer here, but this is a stock pinion support. It uses these two pinion bearings, the same inner and outer. It can only accommodate this 28 spline standard pinion diameter. The dropout case has got, factory ones either have a 2.891 or a 3.062 outer diameter here. This one looks like it's actually the larger case, so it would have the 3.062. But these are the carrier bearings that would come in a stock Ford 9-inch. So this tiny little guy here with a stock old school 28 spline carrier. So if you're building a street rod and you do a Ford 9-inch swap, really, if you have this dropout, one of these dinky bearings, 28 spline axles, it's not all that strong. And, if it's just a mild V8 or something like that, and it's just a cruiser, it's probably not a big deal. But with even some of your more basic LS swaps and things that people are doing these days, really need something bigger and better. But regular Ford 9-inch cores are getting harder to come by. And really, I could take a ball peen hammer and tap it on this pilot bearing support, and it would break right off. They're not very strong, they're not very sturdy. They've been used widely for years because they've been made for years and years and years, and there's tons of them out there. I mean, there's businesses that are built based off of 9-inch only. And it's kind of like, I guess, the small block Chev of rear ends. It's the platform, but once you get into this, you can see that it's not at all the same. So, we've been offering an upgrade for quite a while, so that would be the nodular iron aftermarket case. It's got a lot more gusseting, thicker material. It's got billet adjusters, quite a few things to upgrade it and make it a lot stronger. And you can run the Daytona support, which gets you a larger inner pinion bearing here, and it uses the same outer pinion bearing. So this would still be used with 28 spline. We do have a way you can run 35 spline in here as well that has a bigger pinion support. One of the things about a 9-inch or any differential is to prevent breakage and for a strong setup, it really is, a lot of it comes down to controlling deflection. So with this carrier being thinner and weaker, under load, the pinion wants to force the ring gear away from it. So you kind of got this action. you know, under load, it wants to force it out this way. So if the carrier, or the third member housing, can deflect, it's going to allow the backlash to widen, and, you know, it's going to be a lot easier to break gear sets. So, you know, this case is kind of what is the backbone for the differential setup. So even though you'd use the same 28 spline gear set in this case, or even in one of these with the street setup, it's going to be a lot stronger in here and even stronger in here because there's going to be a lot less deflection. So really, this is a key part of the upgrade. So with this one is a nice unit. You know, it's good for a street car. I mean, you can set this up to handle, you know, it depends on the uses, but for, you know, 500, 600 horsepower, potentially, depending on how you set it up. Some people run more. It's just, you know, there's no set number on something like that. This unit really steps it up. You've got much more material. You know, it's machined out of one big chunk of aluminum. And these are made in Washington State, in the USA. It's got all top quality studs and hardware. The factory bearing retainer for the pilot bearing is just this kind of spring-loaded stamped tin piece. This one's actually, I don't know if you can see it, but it's an aluminum machine piece with set screws to hold the pilot bearing in. It also uses a wider pilot bearing that's got wider rollers for more surface area contact. This area is machined out to allow the pinion to fit, but you know, also prevent a lot more deflection. You can see how there's a lot more material in here. You know, this is a lot thinner. And then the factory one, I've actually built these in the past where these castings vary so much. I've built one that was maybe a 1/4 inch thick over here, and I could push with my finger and dimple the metal here. They're just really, the tolerances are not very tight on these old cast 9 inches. These are a cast, or these are a cast unit as well, but they're machined, you know, both of them are machined afterwards, but this is done in today's world instead of, you know,
1945.
Yeah. So this one, though, is all CNC machined, so the tolerances are really tight. One of the things we found with Ford 9-inch is, you know, there's a lot of hypoid offset, which is the pinion sits really low. There's a lot of sliding action on the teeth as they roll over each other, so it's almost like a corkscrew. And they have a tendency to make noise. And you could take the same gear set and set it up in 3 different factory housings like this, and they'd all set up different, and they'd all sound different, because you can only change the pinion depth in and out and the backlash, which is the position of the carrier side to side. If the bore was coming in at an angle or slightly placed up or down a few thousandths or cocked at all, you can't change that. That's just part of the machining tolerances, which by the time you get into these is a lot more tight. Some of the other upgrades we've got, you know, you can see here you've just got 5 pinion support bolts. Here we've got studs, and there's 10 of them. And then we've got, I mean, you can just see the flange thickness, all the gusseting. We've got studs instead of bolts for the bearing caps. We've got just a lot more material. This one's got a lot. This is a big bore one, so this will accommodate the big 40 spline stuff. This one's pretty new. We've had it already for a while with the 3 1/4 inch bore. For they've been run in lots of Ultra 4 cars, some drag cars, some trophy truck type stuff. This one will be using a spool that's got the bigger bearing journal, so you can see the size of the bearings. This basically is the 40 spline one. This is the 3 1/4, aka 35 spline, and then these are the factory ones. So if you go back to your original old school 9-inch that so many have in their street rod, you can see the huge size difference there. So, you know, based on 9-inch, but considerably different. So we can go ahead and start putting these parts in. We've done some of it just so that this video isn't so long, but you know, we've got your pinion support. The pinion bearings are already loaded. There's a solid pinion spacer in there with shims, so the preload's been set. You know, because the factory diff would have a crush sleeve, and it's a one-time use. You can't ever change the yoke without affecting the preload. This is just a much more rigid setup. If you need to change yokes for different size drive shafts and stuff like that, you can just zip it off and zip it on. The preload won't change. The spool here, it's actually double drilled for different ring gear bolt sizes. So our gears are as well. So we went ahead and used 20 ring gear bolts in this setup.
You want to talk about the bearing size difference in the pinions?
Yeah, here's the. This is the bearing for the larger 35 spline pinion, and here's the pinion support for the 28 spline pinion. This is actually bigger than stock too, but you can see how much bigger this one is. I mean, you've got this. This is a factory inner bearing on a Ford 9-inch Daytona support, and then with our Nitro billet support, and then the outer. The other ones I'll use this for an outer, considerably larger. And so this is a high-end unit. It's all made in the U.S. The gears are limited production in comparison to, say, a regular 28 spline 9-inch gear that goes in most street rods and stuff. So the cost of this unit is going to be quite a bit higher than with the nodular iron. And one thing we've found is that a lot of people are very interested in this, but they don't necessarily need this quite this setup. So we've actually machined some different pinion supports that will take bearings that will allow you to run a regular 28 spline 9-inch gear, and the strength is going to be much stronger than even the nodular housing, but the look, you still get the made in the USA billet machined housing, this same third member housing, which is just awesome for street rods and cars like that the attention to detail is meticulous. And why put a crusty old cast unit in it that's spray painted when you can put one of these in it. And we've got it worked out on the street car version to where you can actually get into this, and it only ends up being $700-800 more than a regular cast iron. Okay, yeah, sorry about that little technical difficulty there. Did you have something to add?
Yeah, why don't you explain to them the difference between a 9-inch gear and the 10-inch Pro gear, and why a car like Doc's needs it? Okay,
so we've talked about the difference in the pinion spline, 28 versus 35. You can see that's a considerable difference there. The other big difference is the ring gear diameter. So this is going to be a larger diameter. And what that does is, when it comes to drivetrain parts like this, a lot of times it's just more mass is stronger. The teeth are a lot longer, so you've got much more tooth contact, on the pinion and the ring gear. So, each tooth is going to be able to take much more load than this style setup. And there's also, these are made out of an 8620 material, whereas these are made of a 9310 material, which is going to be much stronger and resistant to shock load than the street gear. These are kind of designed to run in a car that's getting tons of miles for long-term wear resistance, whereas this is designed to prevent breakage on hard launches and stuff like that. Did you have anything you want to add, Jared?
No, that's good. Yeah, like you said, this is like a daily driver rig, your old muscle car, that kind of thing. For even up to 500, 600, 700 horsepower, depending on how you drive. But for the big boys, this is the gear you want to run.
Yeah, this one will, this is going to go in, like I said, drag race cars, Ultra 4 off-road race cars, Baja trophy trucks, stuff like that. Stuff with a lot of power that gets a lot of abuse. You want to start putting it together?
Sure. It's nice to have this holder for third members.
One of the things we've noticed since we started doing the street car unit with the, with this billet third member that takes the regular 9-inch gears is we've actually been able to eliminate some of those gear whine noise issues that have been so inherent with the Ford 9-inch. And part of that is because, the tighter machining tolerances, but also, go ahead. Also, there's a lot more mass to it, so there's a bit of a dampening effect with the third member housing itself.
It's nice to have all your depth shims lined up beforehand.
So this is just, obviously one of the things we do, this Ford 9-inch type stuff. But, really we do everything. We've got gears for, if you've got a Suburban or Chevy half-ton or something that's just got a blown-up rear end and you need to fix it, we've got regular replacement parts. We've got bearing kits, ring and pinions, carriers, spider gears. We've got a line of limited slip differentials for a lot of popular applications. Another thing that we do that is extremely popular is we do aftermarket gear ratios for a number of applications. In fact, more applications than any of our competition. We do all the common stuff that everybody knows about, Jeeps and things like that, but we also do a lot of the import stuff, Toyota, Nissan, and we try to stay up and current. Traditionally, drivetrain's been pretty behind the times with the applications. We try to have gears available for newer vehicles, kind of as before the competition does. We got, gears for the 2016 Tacoma already, which there's a really big need for. We've got gears for the Canyon in Colorado that just came out. Pretty much anything that you can think of when it comes to four-wheel drive. But also, we do a ton of muscle car type stuff, for your 60s and 70s cars, your Mopar, Chrysler 8 3/4, the 55 to 64, GM passenger cars, all those. Another thing we've got that we do that's another made in the USA product that's extremely popular is differential covers for a lot of popular applications. All your Dana axles, Toyota Land Cruiser semi-float, and then we do an extreme line which is for your off-road applications, and we do another line that's got deeper dish and ribs for cooling. For like your diesel applications and tow vehicles. The one thing with these units that I can say about bringing them to shows and having them on display is, you get a lot of comments. Everybody, it catches their eye, whether they may not even know what it is, and they can see that it's a beautiful piece of machinery. So what these adjusters do is they're threaded, and we'll be able to move our carrier left to right to set our backlash. And the backlash is the space between the pinion teeth and the ring gear teeth. It needs to have a little bit of play because it has to allow oil to pass through the teeth, and it also has to allow for some tooth deflection under load. When you've got tooth deflection under load, the back side of the tooth could actually dig into each other, and so you need that backlash. It helps the teeth roll over each other smoothly.
In a high horsepower application like this, how are you going to typically set up the backlash?
Well, typically you're going to still set it, you know, within a normal spec, but maybe towards the tighter end of things. So we'll probably set this one, you know, somewhere around 6 or 7 thousandths. Another thing we've done that we do with a lot of ring and pinions is we deburr them, you know, so we'll go and dress them, because sometimes with shipping and just handling them and transporting, you'll get small dings on the teeth, which is important for a street vehicle too, because they need to run quiet, and you could get, you know, if there's a little ding on the tooth, it could make a noise as they're rolling and create a high spot. This one we've done kind of a unique deburring process here, where we've actually put a chamfer on the edge of the tooth here. And what that does is it removes the sharp edge that, you know, in a car like Doc's that's going to have a serious amount of power, under deflection, it keeps this back edge from digging into the opposite tooth on the back side of it, on the pinion. So we've just removed a little bit of material there. Doesn't affect anything as far as strength. Normally on a street vehicle we wouldn't take that much off, but this thing's going to get used and abused. The billet cases here we've got, traditionally they've always required a lot of clearance grinding. What we've done is we've done some 3D modeling with different type carriers, the spool, also ARB, you know, some of the popular units that would be used in off-road race application, and we've actually machined out the material to accommodate the larger ring gear. To the ARB has got a different shape here, so it's domed out here, so the material's clearance there, just so you don't have to do as much grinding.
And this case already comes pre-drilled and tapped for the ARB fitting on this side right here.
Yeah, so if you have an ARB air locker, you have to drill and tap the housing for a fitting for the airline to pass through, and this housing's already, you can't really see it that well, but this little hole here on the back side of it, it's actually drilled and ported, so the ARB fitting.
We got a plug in it right there. Hopefully you can tell.
Yeah. This one's plugged because it's got a spool, so it doesn't need an airline, of course.
Somebody asked a question about pinion oiling on this with the billet. Is there anything particular?
Oh yeah. So we've got, you know, we've got these oil ports here to aid with oiling. It's not generally an issue in a normal rear application where the pinion's down low, it's driving on the drive side of the gear. But what we've had is some, you know, mid-engine cars, you know, like Ultra 4 type off-road stuff, that they actually run the third member upside down because it's turning the power the other direction. And so they're actually, the pinion's up high. You know, we've definitely seen oiling issues in a lot of units, and so some of the reason we've done this oil porting is to help with those applications. So as he loosens this side or tightens that side, it moves this way, and vice versa, of course. And then overall, where we get preload on the carrier is how tight the adjusters are.
And why is carrier bearing preload important?
And the carrier bearing preload, it goes back to, as we discussed with the deflection. If the carrier is just snug in there, under load, it's going to have a tendency to deflect, which widens the backlash, and that's where you get your breakage.
About 7 or 8 thousandths
yeah.
right now on this one.
So I mean, Jared, what can you say about, you know, I mean, not necessarily this application, but say it's a Jeep with a Dana 35 or a Toyota 8-inch or, you know, some off-road application, and you get it when the ring and pinion's broken, when you pull it out, what do you usually find?
Oh, usually it's set up wrong.
Yeah, I mean, but
backlash is wide open.
Yeah.
Pinion depth is usually off. Sometimes people don't even realize it requires pinion depth, so they just press the bearing on and throw it in the housing, and then
yeah.
boom.
The other thing is too, is I've had happen a lot of times is, you know, you've got a broken gear set, somebody brings a vehicle in, you pull the cover off, you go to drop the carrier off, drop the carrier out, you unbolt it, and it just falls out. No carrier preload. And usually, I mean, most times we see broken gear set, even in an application that's abused, you'll find that there's no carrier bearing preload. And it could be from original setup, or it could be the carrier bearing under load on this side because it's forced this direction. Sometimes it's a press fit normally, and sometimes they'll spin. And of course, they'll spin a lot easier if there's no preload, and so that just over time it'll walk itself. I mean, sometimes they'll actually be play, so the carrier will be walking side to side. And bigger bearings help prevent that. More preload on the carrier, less deflection on the case.
And that's even important on your daily driver. Plenty of carrier preload when you do this new, because the bearings will wear eventually. And over time, like Carl said, the preload will loosen up, and sometimes backlash will open up. It's just the normal thing. So when you first put them in, the tighter you have it, the better off you are long term. All right, paint some teeth now.
Another thing that we've got here is this load bolt, and what it does is it threads in from the backside here, and it sits right up again, right real close to here. So under deflection, it can only move so much. So the gear could actually come in contact with it, but it won't go any further. This case is not as much of a concern as some of the other. There's some other cases out there that are made that are a cast aluminum that still have this big bearings and everything, and it will take these parts, but since the material is a lot thinner and it's cast, they have a tendency to flex, so these are really important in those applications. We add it as an extra measure, but we kind of feel that it's not actually necessary for a lot of applications. So what we've done here, what Jared did is he put marking compound on the teeth, and we roll the ring gear through the pinion back and forth, and we see where the tooth contact is. And so what we're looking at here is we've got this is the face of the tooth, and the back side is the this is the drive side of the tooth, and the back side is the coast. And the drive side is the side that's receiving the load when you're going forward and on the throttle. So in this car, it's never even going to be driven on the coast because it's a drag car. If this was in a front end, it would be driving on the coast. And that's why there's other gears, not for this application, but that's when you hear about a reverse cut gear. The teeth are actually going this direction and the pinion's up high, and those are typically used in a four-wheel drive front end. So what we're looking for here is we've got the face and the flank and the heel and the toe of the gear set, and what we're looking for with a normal setup is we want it to be fairly centered from flank to face this direction. So we don't want it, you know, way up here or way down here. We're going to pay more attention to the drive side because that's the side that receives the load. And so what we're looking at here is it's got a pretty uniform kind of circular contact pattern. It's going to be down towards this end of it more than it would for a lot of the street applications because there's going to be more degree of deflection. So while in a perfect world maybe you'd want to see it centered in just a regular street application, this is actually pretty good for or really good for this drag race application because the tooth is actually going to deflect under load. On the coast side, you can see it's actually a little bit on the deeper side. It kind of favors the flank of the gear a little bit. And then did you, as far as the backlash, what we used is, I didn't really talk about it, but did you?
Yeah, it's just a gauge. It goes, obviously it goes up and down. So the backlash, when it goes back and forth, that's the gap between the pinion and the ring gear. You need to have that. If you don't have any backlash whatsoever, you're going to burn up a gear in a big hurry. So that's what this gauge does. It just measures in thousandths the backlash, and most gears acceptable backlash is 6 to 10 thousandths. So there are applications that require wider and a few that require less, but overall, on average, 6 to 10 thousandths.
If anybody has any questions out there, go ahead and chime in, and we'll try to answer them for you before we wrap it up.
This is a 2-cut gear, is that correct?
Correct.
So, and a 2-cut versus 5-cut, what's the...
Well, it's just different machining equipment that, a lot of OEM stuff, ring and pinions are manufactured with a 2-cut process rather than a 5-cut. And the 5-cut tradition is the traditional way to do it. And with the 2-cut, you'll have more curvature on the tooth, and it's just a little bit different to set up. I don't really see much of a difference, but maybe if you haven't done, if you're used to one way, the patterns will look different, and you need to set the backlash a little bit tighter than you would. Maybe you're going to be 3 to 5 thousandths instead of 6 to 10 thousandths.
On a 2-cut gear, setting your backlash, you can actually get the pattern to move up and down on the tooth.
Yeah.
So some gears like this one, I've messed with this one before, and this pattern stays put no matter what I do with the backlash. Some stronger 2-cut gears, you can walk that pattern back and forth. 5-cut gears and this gear, it doesn't matter what you do with the backlash, they stay kind of where they're at.
Yeah, it's that extra curvature on the teeth, on the 2-cut stuff that normally to change the pattern, you're only going to be moving the pinion in and out with the depth shims, and then you set your backlash within spec. But if you mess with the backlash on those gears, it's affected a lot more. You'll see the pattern move across the tooth a lot more.
You're going to put the load bolt in and set that up?
Yeah.
So we'll go ahead and show you what that load bolt that I mentioned before does. And as you can see, it's already drilled and tapped for it.
So the Street Beast will be a great place to test the performance of this unit.
Yeah, if it holds up in that car, it pretty much.
It's going to hold up in anyone.
Yeah.
Inch. 3/8 next door down.
So what he's doing basically is
I don't know if you can. Let me get a light, see if they can see that.
What he's doing is he's putting the load bolt right up against the ring gear, and then just going to back it off just a hair.
So it's tight, and then you just. Yeah, you can't even see it on the video because you want just a little bit of clearance.
Yeah, you can see it in there. Oh yeah, there you go.
Yeah, there you go. Yeah, that's tight, and then just back it off, 1/8 to a 1/4 turn. Yeah, that's it.
And then it's got a jam nut to hold it in place. So this is kind of the kickoff. We've been offering these a little bit already, but we plan to expand this line, of high performance parts for your serious race applications. kind of just, aiming at the best there is stuff. And it'll be our pro line of Nitro products. What these are the adjuster locks, and these are a safeguard to prevent the adjusters from actually backing out.
And these are high-grade studs in here, right?
Yeah.
Yeah, so high-strength studs with inserts, high-strength studs on the front with inserts.
All right.
Pretty much it.
That's it.
Yeah, thanks for joining us today. If you have any other questions, message us on Facebook, email us, call us, visit our website. It's nitro-gear.com, and stay tuned for more products. And also keep an eye out for Street Outlaws to see this baby in action.